Hello, today we're going to solve a higher order differential equation. In this case, this is a third order differential equation. So we're asked to find the solution of the equation b minus 1 cubed times y is equal to 6e to the x. To solve this, we have to solve for the yc and yp. So to get the yc, we need to equate the homogeneous part to 0. So when we expand this term, we have d cubed minus 3d squared plus 3d minus 1 times y is equal to 0. We let dy is equal to y prime. So now we have y triple prime minus 3y double prime plus 3y prime minus y is equal to 0. Now, to get the complementary solution, we have y is equal to e to the mx and get its first, second, until the third derivative, and substituting these values to our equation, we have m cubed times e to the mx minus 3m squared e to the mx plus 3m e to the mx minus e to the mx equals 0. We can factor e to the mx in this equation, leaving us m cubed minus 3m squared plus 3m minus 1 equals 0. Now, solving for m, we have m1, m2, and m3 equal to 1, all equal to 1. So it is repeated roots. So this is case 2 of the constant coefficient. So now we have yc, or the complementary solution, equal to c1 e to the x plus c2 x e to the x plus c3 x squared e to the x. This is our complementary solution. After we obtain the complementary solution, we are now going to solve for the particular solution using the variation of parameters. So, our particular solution has a general equation of u1 times y1 plus u2 times y2 plus u3 times y3. Our y1 in this case is equal to e to the x, our y2 is x e to the x, and y3 is x squared e to the x. To solve for the values of u, we will use Russkian. So we have w e to the x e to the x, and x squared e to the x. We will get up to the second derivation of these three terms and use the determinant method to get w, which is equal to 2e to the 3x. So now, solving for w1, the same as w, we will get 6x squared e to the 3x. Using the same method as w, which is the determinant method, we get w2 is equal to negative 12x e to the 3x, and w3 equal to x e to the 3x. After we obtain the values of w, we will use these to get the values of u. So for u1, we have the integral of w1 over w, and substituting these values, we have x cubed. And for u2, we have the integral of w2 over w, and integrating these, we have negative 3x squared. And for u3, we have the integral of w3 over w, and integrating this, we get 3x. And now, to get the particular solution, remember yp is equal to u1 times y1 plus u2 times y2 plus u3 times y3. So we only need to substitute the values we solved for u. So we have x cubed times e to the x minus 3 So now, our particular solution is equal to x cubed e to the x. After we obtain the values of the complementary solution and the particular solution, we will get a general solution of c1 e to the x plus c2 x e to the x plus c3 x squared e to the x plus x cubed e to the x. And now, to get the value of these constants, we have the conditions given. So, when x equals to -1, we get y to 0. So, substituting these values, we have c1 minus c2 plus c3 minus 1 equals 0, which is our equation 1. And for y prime, we have c1 minus c3 is equal to 3, and this is our equation 2. And for the y double prime, when x is equal to -1, y equals 0, we have c1 plus c2 minus c3 equals 0, which is our equation 3. And solving this using the substitution method, we obtain value of c1, which is equal to 1, c2 equal to 0, c3 equal to 0. So now, our new general solution will be and we can simplify this into which is now the general solution or the solution to our differential equation. Thank you.